In this lesson, we'll be using stock for rest machining. After completing this lesson, you'll be able to analyze multiple toolpath options for rest machining, use save options in Simulate to create an STL file, modify the scale of an STL file, and create a distributed design. Let's carry on with the file from our previous example, and I want to make note of a few different things we're talking about rest machining. So far, what we've done here is we've created a lathe operation that started taking our original stock down to size. Then we used our direct modeling tools to create a representation of what was left behind. But I did note that we could simulate this and export an STL file that's based on what material was left behind. I do want to make a quick note about that. Because we are removing this part from stock, when we create an STL file, it'll actually leave both pieces of stock in the file. So this can be problematic, and it does include it as a single body. So when we're trying to use that for things like rest machining, again, it can be problematic. Another thing to note is the potential difference in scale when we export that STL. So you will have to likely scale the file down, especially if you're working within the inch unit system. From here, what we want to do is we want to take a look at a few different operations, and we want to see what the options are for rest machining. The first of which I want to explore is our turning profile. So if we edit this and we go to our geometry section, we're utilizing rest machining, and the only option is from previous operations. Notice the tooltip displays that we have the option to do from tool, from file, from solids, and from setup stock. So while those options are available in some operations, it's not available when we're talking about this turning profile. Let's explore one of our contour toolpaths. If we take a look in the geometry section here and we turn on rest machining, the only option we have here is to select a tool diameter and a radius value for that. When we talk about a radius value, this means if we're using something like a bull end mill or potentially even a ball end mill, we need to enter that value, and it's used to calculate the material that's left behind from a previous operation. Now in this specific case, when we created our setup for our milling operations, we automatically used this solid body that we created as a representation of the stock. So we got around this by creating that body and not having to worry about rest machining. However, there are some other operations that can make use of rest machining. When we're talking about our 2D toolpaths, for example, things like pocket or adaptive clearing, when we take a look at their options, they're going to be similar to our 2D contour. We can enter a tool diameter and a quarter radius, and that'll allow it to calculate the material that's left behind that's representative of stock. However, if we go into some of our 3D tools like adaptive clearing, we take a look at the geometry section. Rest machining allows us to do from stock setup, from bodies, which will allow us to select a body in the file, from file, and from previous operations. So from file is an option that we could use if we were exporting an STL from simulation. The requirement here is to enter the file location, and there's no navigation dialog box that lets us open up an explorer and search around for our file. We need to know the location of the file, the name, and the file extension. But again, keep in mind if we're doing things like exporting stock from simulation, that we need to make sure that the file is the correct orientation and scale. So if we take a look at setup 1 and we simulate it, and we run all the way through to the end, again noting that we do have two bodies in here, if we right click and we go to stock and we save the stock externally, that STL file will contain both bodies. This is also included in the dataset folder, and if we upload the STL file, we can take a look at what the file is. You notice that it's saying it's an STL, which is a 3D object file, or a stereolithography file, and it's going to come in as a triangular mesh. Once the file is loaded, let's go ahead and double click on it and open it up inside of a design. So now that it's open, we want to note its orientation. Z plus, and if we show our origins, the origin is located at the back of the part, and Z plus is pointing up and away. If we take a look at the file that we exported it from, the coordinate system for our milling operation and our lathe operation is based on the end of the part. However, the coordinate system for the actual part, if we go back to the design workspace, is on the back side of our face and it's pointing away. So the orientation of the part itself doesn't match the orientation of our coordinate system in our milling setup. We also want to note the scale and orientation of the part itself. While we've already noted the orientation, if we go to inspect and we just measure some of the geometry, for example, going from this edge to this edge, we're looking at 65 millimeters. If we change the file units to inch, and again we inspect this, you can see that we're talking about 2.5 inches. If we go back to our original file and we inspect, and we go between these two faces, we're dealing with 1/4 inch. So there is a scale difference between the files and a difference in their orientation. If we were to drag and drop the stock into this design, notice that the orientation matches if we hide it, but the scale does not. So if we bring this in and we say OK, we go back to its original file, we'll need to scale this down. And if we expand this, it's a single mesh body, even though they're not touching. So we would need to make some modifications to it inside of the mesh workspace. And we would need to remove the secondary section of bodies. And then we need to use modify, and we need to use our scale operation. And we're going to base the scale from a point, and we're going to use the origin point. And we need to scale it down based on the differences between the original body and this body. So we're going to be scaling down our mesh body, and the amount we're going to be scaling down is a difference between the distance that was 2.5 inches down to 1/4 inch. This will give us a scale value of 0.1. Once we do that and we save this file, back in our mill turn example, we'll need to update to the most current version. And now you can see that the files are located in the right place and the scale is correct based on the difference between the two. So there is a little bit of an additional workflow that has to happen when we're trying to utilize these STL files. While we could directly put the file location of that STL and use it for rest machining and checking against the file, we do need to ensure the scale and the orientation are correct to ensure that the results that we're getting from rest machining are correct as well. So depending on, again, the complexity of the file, it might make more sense to export an STL from simulation, or it might make more sense to come back into the design workspace, copy the original body, and modify the features to represent the current version of stock. In this case, I'm not going to save the version with the STL. I'm going to go ahead and close this out because we're done modifying this file. And once you're done playing around with it and exploring the options for exporting that STL file and re-importing it, scaling it, and working with it, then go ahead and make sure that you save and close your files as well before moving on.